Question 5. Question 5 says, the points P and Q have position vectors relative to the origin are given by P is -1, minus I 6j, Q is 3I plus 8j. Calculate in degrees the size of the acute angle theta between P and Q. So first thing, to find the angle between P and Q, we need to find OP dot OQ. So let's go ahead and do part I right here. So all we're going to do now is say OP dot OQ, OP dot OQ, that is going to be equal to OP dot OQ, that is going to be equal to -1/6 dot OQ, where OQ is 3/8. OQ is 3/8. So find this dot product, and what we're going to get is this works out to be -1 times 3 is -3, plus 6 times 8 is 48. And so what we get is 45. That's what we get for the dot product. All right, 45, nice and easy, soft. The dot product is 45. Now that the dot product is 45, we also need the magnitude of OP. The magnitude of OP, that's going to be the square root of, magnitude of OP is the square root of -1 squared plus 6 squared. So the magnitude of OP is -1 squared plus 6 squared. That's the magnitude of OP. So when we work this out now, what we're going to get is -1 squared is 1, plus 6 squared is 36. So that works out to be the square root of 37. That's the magnitude of OP. Then now we need the magnitude of OQ. The magnitude of OQ is going to be equal to, find the magnitude of OQ, it is the square root of 3 squared plus 8 squared. Nice. 3 squared plus 8 squared. That's going to be the magnitude of OQ, and the magnitude of OQ is therefore the square root of 3 squared plus 8 squared. Square rooted, that's the root of 73. So to find the angle between them now, so to find the angle between P and Q, the angle between P and Q, they call it theta. Theta is therefore going to be equal to cosine inverse. It's going to be cos inverse of OP dot OQ, which is 45, divided by the square root of 37 times the square root of 73. So that's all we're going to do. And it says, given your answer, calculate in degrees. So we give our answer in degrees. Square root of 37 times the square root of 73. You put that in your calculator. Square root 37 times square root 73. And I have 45 divided by that. And then I want to take cosine inverse of that. I'm getting, is that 30 degrees? I'm getting 30. Let me just check one last time to make sure I didn't make any calculation error. This is 3 squared plus 8 squared. Yeah. All right, so I'm pretty confident in this answer now. Square root that. So I get 30 degrees is my answer. Roughly 30 degrees. Nice and easy. So 30 degrees. That's the angle between P and Q. Then it says calculate the area of triangle POQ. So to calculate the area of triangle POQ, I like to draw a sketch. I just love to draw a sketch. Before I do anything, I draw my sketch. Why? I know that Q is the point 3, 8. So let's say this is 3, this is the point 3, and this is the point 8. So then I know that this is my point Q. This would be Q. Then we know that P is the point minus 1, 6. So if P is the point minus 1, 6, let's put minus 1 right here. And this is the point 6, let's say right here. So this is P right here. That's P. And we want the area of this triangle. OPQ. So this is O right here. That's the origin. We want the area of this triangle from P to the origin. Then we need from Q to origin. Then from P to Q. Now, how do we find the area of a triangle? There are many ways to find the area of the triangle, but since we already know the angle at O, and we know this angle, the angle between P and Q we found is 30 degrees, then we can say that the area of the triangle, let's call it AT, the area of a triangle is equal to a half AB sine theta. The area of triangle is a half AB times the sine of theta. That's how we find area of triangle. So in this case, the area of the triangle is going to be equal to a half A, which is the distance OP. The distance OP, we found that is the square root of 37. Yeah. Then we need now the distance B. The distance B is the square root of 73, root 73, times the sine of theta. What is theta? Well, theta is 30, so it's times the sine of 30. You put all of that in a calculator and that gives you the area of the triangle. Square root 37 times the square root 73 times a half times the sine of 30, and that's roughly 13. I'm getting 12.999. That's roughly 13 units square. That's the area, 13 units square. Easy. So now that we get the area, let's see what else is happening. Let's say find in terms of I and J the position vector M, where M is the midpoint of PQ. So if M is the midpoint of PQ, M is the midpoint of PQ, M the somewhere right here, so M the somewhere right there, so remember now to find the position vector of the midpoint OM is equal to a half, OP plus OQ. So it's a half of OP plus OQ. That's how we find the midpoint. A half of OP plus OQ will give us the midpoint. So a half of OP plus OQ, it's going to be a half of OP plus OQ. Let's add them. OP is minus 1, 6. Minus 1, 6 plus OQ, where OQ is 3, 8. So now we're going to take half of that. And so what we're getting is minus 1 plus 3 is 2. Half of 2 is 1. And then 6 plus 8 is 14. Half of 14 is 7. So that's the position vector of the midpoint. OM is 1, 7. Of course, they like to write it in IJ form. So you should write that OM is I plus 7J. That's OM, I plus 7J. Easy, soft, nice. Then what else they ask for now? They said that R is R, where R is such that PQRO labeled clockwise form a parallelogram. PQRO. PQRO. PQ. Somewhere here is R. We don't know where R is. I'm just going to put a rough guesstimate. Somewhere around this line should be our point R, such that it forms a parallelogram. So I'm just making up a point right here. Let me use a different color. All right, so somewhere right here should be R, such that it forms a parallelogram. If it forms a parallelogram, that means that this side is going to be parallel to this side. Let's write that down. If it is parallel, that side down there, if P, Q, R, O, if P, Q, R, O forms a parallelogram, then what do we know? Parallelogram of two pair of parallel sides. If PQRO forms a parallelogram, then we know that OR, the length of OR, we know that OR, or the direction of OR is going to be equal to the direction of PQ. Right? That's what we know because they are parallel. Yeah, so we know that OR is equal to PQ, but didn't we find vector PQ? Oh, no, we didn't. So let's find vector PQ right here. So that means that the position vector of OR is going to be PQ, which you know is OQ minus OP. OQ is the point 38. This is 38 minus OP. And OP is, there is OP. OP is minus 1/6. Yeah. So what we get is 3 minus 1, which is 4. And then 8 minus 6, which is 2. And so vector OR is 4, 2. Since vector OR is 4, 2, good. See R here? R is the point 4, 2. We're going to verify all of this to you, of course. Nice. So we're good to go. So just to write down the solutions again, calculate the angle in degrees. Right here, this is 30 degrees. Calculate the area. We got 13 units square. 13 units square. The midpoint of OM, we had gotten that to be, can remember the midpoint? We gotten the midpoint to be I plus 7j. This was I plus 7j. That was OM. And then we had gotten R. We gotten that OR was equal to 4I and something something. 4I plus 2j, I believe. Let's check again. 4I plus 2j. Nice. So of course, we're going to verify all of these solutions. Let's go ahead and verify them. So going to Geometer Sketchpad, of course, that's rectangular grid. And P is the point minus 1/6. So here it is. P is the point minus 1 is here. 6 is here. This is the point P. Let's label the point as P. That's your point P. And then we know that Q is the point 38. Q is the point 38. This is 3, this is 8. That's your point Q. And now we need to find the angle between P and Q from the origin. So here it is now. Let me hide these points. Those points look confusing. Hide those points. Hide the origin. Now this would be OP right here. And this would be OQ. We're going to find the angle in between. So let's find that angle there. This angle now, angle between P and Q, just go to measure. And they get 23.7. What did we get for our answer? That's not what we got. we got 30. So let's see what happened. All right, let's see, it's minus 1 times 3. That's minus 3 plus 6 times 8 is 48. That's 45. Then we said minus 1 square plus 6 square. We work that out. Minus 1 square plus 6 square is the square root of 37. That's fine. Then we got OQ is 3 square plus 8 square. And we square root that. That's OQ. So theta is cos inverse of OP dot OQ. So let's just work this out again because we got 30 degrees. 23 is a little off. 45 divided by the square root of 37 times the square root of 73. And then 45 divided by that. And cos inverse. That should be 30 degrees. So let's check that one more time. Because that is the angle between P and Q. Ah, I see what is the problem. The problem is we didn't label this. Minus 1, 6 is right here, but this is not where OQ should be. OQ, Q is the point 3, 8. That is where OQ should be. And then OP shouldn't be right here. OP is minus 1, 6. Which is right here. There it is. Now we get it right. I didn't put the coordinates properly. Let me show the coordinates. So this is minus 1, 6. And then this Q is now here it is now. Finally, I get it right. This is the point 38. Yeah, so the angle is indeed 30. So good with that. Nice. The next thing we were going to justify is that the area of this triangle POQ is 13. Let's justify that now. Remember, I rounded off. So if I were to close this up, all right, and I'm going to just go to art. Just going to create a triangle simulating this so we can find the area. There's the area, 13. That's the area. Here's the area, 13.05, roughly 13. Just like what we got. The area is indeed 13. Nice and easy, soft. And the next thing we're going to verify is that M, the point M is I plus 7J. So remember we said M is the midpoint, I plus 7J. I plus 7J is 1 plus 7. See it here? This is the midpoint for true. This is M for real. That is M. Yeah, label the point. This is M right here. Makes sense. See there? The distance from here to here is the same as the distance from here to here. That's evident. So indeed, we get the midpoint right. Then we said that OPQR forms a parallelogram. And we said that our point was 4, 2. This would be 4, 2. If this is 4, 2, let's see what happens. And we said this is the point R, so such that it forms a parallelogram. Label the point as R. This is not E, we want to label it as R. Just want to move that out of the way. So let's go look at this now. This is the point R42. See the parallelogram here? This is the parallelogram. How do I know it's a parallelogram? This and this are equal triangles, and PQ is clearly equal to OR. This shouldn't say C, it should say OR. We can clearly see that it forms a parallelogram. Because if we're to measure the distance from P to Q, if we're to measure that distance, you would definitely see that PQ and O are equal. So measure that distance, PQ is 4.48. Measure the distance, OR, you're gonna get 4.52. There it is. And the only reason why we don't get the exact values because I don't exactly label the point where it should definitely be. So this guarantee and show that this is a parallelogram. Nice. So good to go. Nice. Easy question. So